My name is Dan, and you can actually see me. I'm on camera, and this is really weird, but yes. So, um, in the lower right-hand corner, you see me. In the upper left-hand corner, you see, oops, the other way. You see a little prompt that has a $sign at the end of it. And what I'm going to do is talk about and get involved with a little bit of programming here, um, specifically C. Why C? It's something I'm familiar with. It's something that I like. Um, it's very small. The language is very easy to learn about. Um, it's changed over the years, but essentially it's um, very much the. It's very easy to grasp. Uh, though when you build very complex things with it, naturally it gets a lot more difficult to comb through. I'm going to be building a series of relatively simple programs, um, or maybe working on one uh, more complex program, just to show some features and things. Now, C has been around for, I'd like to say, 40, almost 50 years at this point. Um, maybe even a little bit over 50 years. And it's used in everything from uh, microprocessors in your microwave, in your car nowadays, I'm sure, in your computer, in various microchips in the computer. Just about anything that has a microchip in it may have some sort of C programming in it that allows it to carry out some important function. Um, so yeah, what is a C file? What does it look like? Well, the C file, let's call this one main. I'm just going to use my own text editor here, is main.c, the file I entered. So every C file will have a .c extension. And it looks like the bare bones minimum uh, C file looks like this. Oop, try that again. Or it can look something like this. You have an entry point of main function, so main with some parentheses around it. Um, Depending on the revision of C we're working with, void may be optional, or you can also insert other arguments in this space here. By convention, sometimes might use int argc and char star argv. I'll get into the details of the convention a bit later. But this is uh, what a typical start of a C file might look like. Does it do anything? Arguably no. I mean, it'll instantiate for a quick moment and then it'll exit and be done. It'll be cleared from memory. But functionally, from where we're sitting as a user, we won't see anything happen. So if we want to do something more interesting and or perhaps even useful, let's store a variable. Um, Before I talk about the variable, however, I'll quickly say, and going in hand with the variable, so you need to make sure you prepend the main with int, which stands for integer, which is a type. So that declares what type of function main is, or what it returns, excuse me. So it returns an int. So subsequently at the bottom, we need to make sure at the end of our main function, we return a value. By convention, 0 is the OK signal, if you will. So anything apart from 0 might carry some sort of an a hint of an error. So by convention, ultimately, return 0 at the end. So we've said, I've mentioned about int here before the main title of the function here. Similarly, we have these two parameters, these two arguments, argc, which is an int, and then this funny looking one here, star argv, which is typed as a char or char character type, essentially. And this asterisk indicates that it is a pointer. A pointer essentially turns this into a variable that points to a memory address. Or rather, the data it holds is not a number per se or a character. It holds a memory address that is some other location, or it could refer to itself, which would be probably a bad thing. But for what it's worth, the star right in front of this memory address. And it points to a memory address of type char. And that's important. You want to always make sure that if you're associating with a variable, like a regular non-pointer variable, that they are the same type, or that they are changed or cast to the same type, which may introduce some weirdness. So there are a lot of sidebars and exceptions and things that need to be discussed. But for what it's worth right now, this is a bare bones main function. This is what that looks like in C. So this is your start and your end of the program. Everything else in between everything else in between will show the computer what to do. I lied a little bit. So let's say we want to make a variable. We instantiate a variable. Let's call it int x. So we have an integer x, and we set its value to 1. So somewhere in memory, we have a variable that is type int, which means it's an integer type that is so many bits large, that holds the value of 1. And now we want to print it. So a standard function to print is printf. And there, I'll type in some notation here, or syntax. There we go. And let's just put in some other text here, just to be sure. Value of x. So the expectation is that the computer will print out value of x, and then there's this placeholder %d, which determines the type of data that this whole bit of quoted text is expecting. The quoted text I will refer to as a string, because that is conventionally what it's called. So this will be a type decimal, or if we wanted to be actually more proper, I should probably use I for integer to reflect it's an int type. And then we have a \n, and even though this appears to be 2 characters, this is really treated as 1 character, as an escape n, and that means that this will create a new line. So after value of x colon, and then whatever data is here is printed, it will go to new line. And that's important if you want to format your output properly. So we also type in the variable here after a comma, and that hopefully should still say 1 in place of the %i, obviously because we have this line here that instantiates x and assigns the value of 1. So after all that explanation, let's compile this and let's run it. So remember when I told you I lied about everything in between? You want to make sure that, as the screen indicates just above the cursor here, include stdio.h, or provide a declaration of printf, which means I need to type in an include directive, and within the greater than and less than brackets, stdio.h, and that will, like the line might imply, include the contents of the file stdio.h, which also incorporates definitions for printf, the function, so that the compiler knows to process that, and the computer knows how to print to the screen. So let's try that again. And let's take a look. Let's see what the output is here. So we've got a.out. If I recall correctly, the a.out convention, outside of any user-provided output file name, is a result of assembler, which is a predecessor to C and other languages. And I think that was sort of derived. That output file name was derived from that. Someone else could comment in on the history of that file name, but suffice to say that that file can be run or executed, and now we have the value of x is 1. Great, so we've assigned a variable, we've instantiated a variable, so maybe we want to do more things. So let's create another. We can do some mathematics, some very complicated mathematics. Let's say the value of x minus y. Extremely hard. So now we can say value of x minus y, and we compile again. And the value of x minus y is minus 1. So very easy to see, very useful for arithmetic functions and the like, multiplication, division. There are other libraries for more complicated types of mathematical functions that are not native to the C compiler by itself, but very simple mathematics and like subtraction, division, multiplication, addition. Those are already included without having to import any other header files. That doesn't preclude you from inventing or creating your own functions, but we already have the math functions on hand, so why wouldn't we include those anyway? So we want to say now we've got these values. Oh, also, let's say we want to create a character variable. Let's call it C for the heck of it, and let's call it A. The value of C is going to be %C, which signifies character output. And we want to make sure that we include C, the C variable there. And value of C is A. Pretty cool, right? Now, what if we wanted to do something like asking for your name? You know, what is her name? And it spits it, but the program gives it back to you as a response. Well, there are a couple of things we can do. Well, there are some things we have to do, and there are a couple of things we can do. So, if you are not familiar, there are objects in C called arrays, and those can either be statically allocated or they can be dynamically allocated. Statically allocated arrays are designated as, at least as I would refer to them. Someone will, of course, feel free to comment and correct me. Let's take our variable name, for example. I'll just call it name because that's easy. And we want to then give it a number between the square brackets here. Let's call it 25. So now we have a variable called name with 25 extra spaces after it, if you will. So it's one character plus 24, or a whole total of 25 bytes, because each character is a byte. And now we want to make sure that we scan it. Now, there is a way to get it. If I'm not mistaken, it's been a while. All right, let's do a little quick search here. Okay. So we could do fget_s, name, and then we do the number of integers, let's say 50, a number of characters, excuse me, 50, and then the file name would be stdin. And I may have to include some other things for this. Let's see. Right. Okay. So I will have to get, or include rather, stdlib, and I think string.h. Oh, there is also an issue of right. I looked at 25 and I wrote out 50. Let's try it again. I'll clear this first. Okay. So I don't need stdlib, which is a standard library of other functions, like for allocating memory and other things, and string.h, which is for string handling, although fget_s is included in the input-output stdio.h. So let's run this. And I just realized I need to create a prompt and also create an output. This is your brain when you've had a long day. So enter your name up to 25 characters. Now we want to make sure that we print out what the actual name was, just so we can confirm that. You, or say, nice to meet you. Okay, friendly program. Excited friendly program. Now, provided nothing weird happens because I misprogrammed something, which could always be the case. Well, so it works as it was programmed. It did not work quite as expected because of the exclamation point being on new line. Why is that, you ask? Well, the new line occurs before the exclamation point and after the string because the new line is incorporated when I press enter, which happens when this function is invoked, when it's taking the name in. It's also taking in the new line as a character when I press enter. So what I want to do is make sure that I capture that last character and then I swear this worked before. Okay, well, maybe not. Suffice to say that this works without that. Let's try it with that again. I don't claim to be an expert. Huh. Okay. So, if anyone wants to help me out on that in the comments, please feel free. If you like my follies, please click on the like and subscribe buttons, and so on and so forth. But we do have an ability to get a string, and we have the ability to print it back out. Now, going on further, what if we wanted to create a character of sorts? And a character, I mean like a virtual playable character in some hypothetical game. You might know from experience of playing role-playing games, if you've done that sort of thing, or if you can just think of a game that you've played or seen someone play. They might play a character who has a bunch of different attributes, say health, strength, movement or agility, and all sorts of things like that. And so that might be incorporated into a structure of attributes that in part or in whole define our hypothetical virtual character, player character. And so C has a structure for this, handily called Struct. And so we define it like this, and we will give the struct a name. Let's call it struct player. Now, we have char name. So instead of having that here, let's take this, put it here. Okay? And now, let's say health, for example. Let's go with that to make it simple for now. So this is in and of itself another type of variable that you can declare that will contain the two variables name and health. How do we do that? Well, we do this. We do struct. Let's call it struct player, and then p. There we go. Enter your name up to 25 characters. And now, we just add the p dot before the name. And that tells us that name is a part of p. Similarly, let's initialize p dot health to 100, because that's a nice round number. Your health level is at I, because it's an int, p.health. While we might still have the problem with the exclamation point, the idea should still hold here. So as long as I've programmed everything properly, let's compile. No errors on compile, which is nice. Hopefully we won't have any runtime errors. Your health level is at 100. Okay, so great. We have established several different things here. Struct, going from the top down here, that a C program can incorporate a header file, in this case stdio.h in this example, uh, differing types of variables, including variables that are data structures that contain variables. Struct player, which contains car name and int health, and the entire program is invoked with an entry point of main, which is a function that returns an int and can take two arguments, argc and char argv by convention. And then we have the meat of our program, if you will. We declare a player, a struct player called p, assign its variable health to 100, and then we take some user input and we print it back out using printf. And oh yes, there is, I think, one more thing I wanted to go over. So let's say we wanted to make sure that this data is available for future use. So you see, there are variables out there that are called pointers, which I indicated with the argv one, the argv variable with a star previous to it. It's actually a pointer. It holds a memory location, or in this case, a storage location. In the case of this new type of variable I'll come up with. Or pointer variable, I should say, new type of pointer variable, which is file. So I'll call it file pointer. And file, as it's written there, is actually a macro that's included in stdio.h. It's got all sorts of fancy code behind it that allows it to work to process files in a very basic manner, to open them, close them, read them, and write to. And then, so what we do here is, after having declared our fp pointer to file, we want to make sure that let's say we want to store our character data. We do this. We want to make sure that we use, getting ahead of myself here, fp. We want to make sure that we open our file, and let's create a macro. I'll bundle up a few different things here. Default file, and then we want to make sure that we give it write access so we can write to it. So we want to make sure that W is our option here for our default file. Upon reaching that line, fopen will open that file whether or not the file exists, which may be good or bad depending on the thing that you're doing. Say if you already have a file by the name that you choose, then you don't want to overwrite it. So it's always good to build in a check, because C does not do that by default. So let's call our default file, let's create a macro here, and define macro, hashtag or octothorpe or crosshatch, default file, let's call it file.text. So wherever default file, as written here, wherever that is found in the program, it will substitute default file for file.text, which is kind of nice if you've got variables that you know you're going to be using that may change their values. You may have various places where you might want to change the values of those variables. Instead, it might be nicer to use a macro if you know, say, like a file name might need to be changed depending on circumstances. So we have fp open default file write access. And now we want to do the following, to fwrite the data. And let's take a look at the definitions quickly here. So the fwrite function, actually I'll save this for a moment. Oops. Fwrite. I'll just leave that at that for now, like that. And I will bring up some manuals here. So the the function, which is also related to fread and fwrite, involves file input and output, in this case writing to a file. And the nomenclature is typically consisting of a const void pointer, and that will typically be your file name, the size of the data that you're writing, the number of members that you're writing, usually of the same type. Oh no, I'm sorry. So this is the actual data that you're writing, the size of the data, and the number of members. So we could say, if it's name, for example, we could substitute 25, and the number of members would be 1. And this would be output to the file stream, which is FP. So data, the size of the data, the number of members of that data, if there are multiple iterations of that, and FP. So let's see if I can remember all that after switching screens. So fwrite, the data, which would be p.name, the size of the data, 25, the number of members, and the file. We'll do this again for p-health. And in the case of the size of p-health, it is an int, so let's do the size of int. Number of members is 1, and the file pointer. It's very important to avoid any issues to also remember to close your file. Okay. So now, outside of any potential errors we might see here in the compiling, which we got, fwrite makes pointer from integer without a cast. Huh. Pointer from integer without a cast. Okay. Why don't I do this? Size of p.health. Pointer from integer without a cast. Size of p-health. Let's call it 1. See what happens. This is where I get a little funky and try to... Oh, I see what happened. Okay. Right. So I know what happened. This is pointing... Oh, well, I should not say pointing. p.health contains the variable. The expected argument is a memory address. So the address operator, which should precede p.health, needs to be used. That is where my folly lay. It's been a long time since I've done it, done C clearly. All right, so now we want to make sure there's no file of text yet. Okay. Now, let's run our program. Make sure my name is here. Nice to meet you. Your level health is at 100. I'd like to be at full health, because right now my health is not so great, but I'll take it for what it is. But for the sake of the program, let's take a look. Did we output a file? We did. All right. What are the contents of the file? Dan and some characters that don't look like 100. Okay. So that's interesting. I'm not sure exactly what I'm missing here. p.health. Maybe that's what the problem was. All right, so let's remove file text. And let's compile. And let's run it. Enter my name. Okay. Almost look like it's saying Bud. I'm perplexed. So that shouldn't make a difference. Right. So what is happening here is it's taking the address of p.health, p.health. And instead of writing the value contained in there. So I'm not sure what's happening here. That's not going to work. Right. So again, not an expert. I know I can write a string to a file. I can write apparently garbage of an integer to a file. Similarly, I should be able to read from that file. But I will fix this, and I will carry on next time. But for those of you who are entertained by my follies here, feel free to follow along. For those who were not, that's cool. I get it. It's very dry matter, but it's something I like to do, and I'll probably make another one around the same time, maybe tomorrow, or maybe Friday. Well, thank you very much. I'm terrible at goodbyes, but I will see you around.